In the previous two topics, I talked about some necessary preliminaries about the course. For example, in topic 2, I talked about cryptographic hash function and in general cryptography, RSA and elliptical curve. And also we saw that elliptical curve cryptography is used in Bitcoin and many other cryptocurrencies. Now, in this lecture, we start talking about cryptocurrencies, and since the heart of each cryptocurrency is transactions, we start this topic with transactions.
Right, hello. We're now ready to start looking at transactions in a bit more detail. We're going to look at a few in this topic. We're going to start with the mother of all cryptocurrencies, Bitcoin. And we're going to end up thinking about our own, and our own will be some combination of Bitcoin and Ethereum. So it's good to understand both Bitcoin and Ethereum. Okay. Transactions in Bitcoin, right? Okay, well, we've talked about this quite high level now, and the point is that transactions are really the heart of Bitcoin. I mean, they're the fundamental object. They're the thing. Transactions refer to the transactions. Everything's a transaction. We don't really think in terms of accounts or wallets so much, really. The wallets is sort of added feature. It's really all to do with transactions, and I'm hoping we can make that kind of clear in this lecture. So this picture is from the white paper, and what it's showing us, among other things, is that the transactions kind of chain. So each transaction refers to the transactions earlier, and if you chain back, you get back to where the bitcoins that were created and that are spent now were originally created. So that's not necessarily all the way back to the first ones. There are other ways to create bitcoins, and we will learn about that in a couple of topics from now. It's called Bitcoin mining, but but it does chain back, and every transaction is referred to earlier transactions, and that's what we're going to learn about in this lecture. We're going to learn about the verification of all of these in the next topic. But in this topic, it's about how that works, the kind of the way that the transactions refer to each other. Okay, so we kind of get this kind of chain of reaction, chain of transactions. This is a diagram from the white paper. As I said, we'll explain the way this works, and we'll explain the verification in the next topic. I'm not even going to bother getting out of the way. It doesn't say anything beyond what I've just said. Okay, so this is a different picture altogether. It's a rather simpler picture, makes different points, and it comes from the paper that's there. You don't really need to write it down, even if you wanted to learn it, because you can use it. You will have it in your notes. But here we've got a picture of 2 or 3 transactions, actually. Transactions A, B, and C. It's not what transactions is really called, but let's go with it. And the main point I want to make in this, and I think it's really the main point being made by this picture, is that the inputs transaction C is spending bitcoins, it's getting its bitcoins from earlier transactions. And the point is that the inputs to transaction C are related to outputs on transaction A and B. So I've got 2 inputs and 2 outputs. That's just coincidental. In fact, a transaction A has 1 input and 2 outputs. Okay. So with the inputs to transaction C refer to previous transactions. In fact, it refers to previous outputs on transactions. That's really important. So we will make that point here. So transactions have inputs and outputs. An input has two parts. One of them is a description of where the money comes from. And that's two things. It's the transaction and it's the output. So in this particular case, this input here takes its Bitcoins from the output of transaction A, the first output of transaction A. Actually, I should say 0, because they count from 0. It's an array, really. But it doesn't matter. It just takes from one. So I have to say what transaction it is and which output. So it's not just from which transaction, it's which output, because it could be, and there frequently are, more than one output. Okay? So that's one thing. So that's one of the things that is part of the input. It's saying, the input saying where it's getting its Bitcoins from. The second thing is more complicated. And there's sort of two bits of this. There's two bits of seeing this. We'll really talk about the SIG script or signature script, not so much the witness, which is related. And what it usually is it's a signature of the person sending the money. So we've got, and we'll learn more about how the signature works in the next topic. But we've got essentially on the input, it's saying where it's getting what output it's getting its money from, and it's having a signature that the person sending the money, the person who had received that the last transaction that we're now taking the output from, signing that as a way of saying, yeah, that's fine. And that's called a SIG script. And it can be fairly complicated. The Bitcoin language isn't that expressive, but it does allow certain things beyond just the signature, and we'll talk about that again in the next topic. Okay. The output also has two main parts. It has the amount of money being transferred. Okay, so remember, I noticed when I talked about the input before, I didn't say anything about the amount. I just said where it's coming from. This is telling the amount of money that's on the output. And the other thing is kind of the equivalent, in fact, the thing that complements the SIG script is called a PK script, or sometimes a script pub key, and that's a public key script. It essentially is it's something that's saying on the output under what conditions somebody can take that output. Okay, so that output, so the money sort of is sitting on the output, ready to go, and that's the point. That money is sitting on the output, it's ready to go, and what the transaction is saying is, here's the money on the output. Under these conditions, you can take it, essentially. Okay, and there's two things around that. There's a public key. That's why it's called a PK script, or script pub key. The main thing is it's a public key, and the public key, when you hash it, you get the destination address. Okay, right? And it also has a signature of the person whose address that is. So, or rather, these are the things that it's not. Those aren't part of the PK script. It's what the PK script is waiting for, right? So the script is giving conditions under which you can spend it, and it's when it sees this stuff. That's the point. And it can be more complicated. So, for example, you might have it something saying, "Well, I need to see 3 keys out of this group of 5." Okay. So a couple of things that have come up from here is that a public key that when hash yields a destination address tells us that the addresses are hashes of public keys. So addresses of where Bitcoins get sent are essentially hashes of the public key that's involved in securing the transaction. The other thing is to think that the SIG script is the unlocking script that satisfies the conditions placed on the outputs of the PK script. Remember, when I talked about the PK script, I talked about it as making conditions under which you can send it. When I talked about the SIG script, we talked about what's in it. It's essentially the SIG script is the unlocking script for the PK script. That's what happens. And here's a picture that's colorful, if nothing else. That's giving us the sense of the outputs of the PK script, looking at this SIG script. Okay, this is quite abstract, I can see that. So what I'm going to do is going to run through a kind of examples, it's still pretty abstract example codes, but a kind of transaction. Okay, now here we are. We're gonna run through a transaction creation. Okay. So we've got Alice. It was kind of a bit wonky. And we've got Bob, who's got actually bizarrely almost the same wonkiness. Okay, and Alice wants to send Bob money, right? So she's going to do a transaction. She's going to send a Bitcoin or something. Send a Bitcoin. She wants to send a Bitcoin to Bob. Okay, so that's a transaction. Yeah, all of that's a transaction. That's the most usual kind of transaction. So it's not the only kind, but it's a kind most worth knowing about. Okay, so there's 3 steps. We're going to look at 3 big steps for doing this. The first thing is Bob, and you won't be surprised because we've done this before someplace. You won't be surprised to know that for Alice to send Bob something, we're starting with Bob. Okay, so first point, Bob makes an address. That's the first thing. That's the first thing that happens. Okay, how does Bob make an address? Well, what he does is he creates a pair, creates a key pair. And the way he's going to do that is with elliptic curve cryptography. So he's got a public key, which we'll call PK, and he's got a private key, which we will also call a secret key, so we can call it SK. Otherwise we'd be stuck with 2 PKs, and that's not going to help us with anything. So he's got this pair, PK, SK, of a public key and a secret key. Okay? Right. So far, so good. I think you're all with me so far. We know about public keys and secret keys, or public keys and private keys, and we know about a little bit about elliptic curve cryptography, which is the way he does this. Okay, now, the next thing he does is he takes out his cryptographic hash function, which we should know now is SHA-256. So using SHA-256, he hashes his public key. Okay, so he replies his hash function to PK. Right. Okay, so the hash applied to PK is his address. It's not where he lives, but it's the address where he wants the money to reside eventually. So that's his address. So he sends that to Alice. Okay, so Alice now has Bob's address, right? So that's all she's got. She's got Bob's address, and she knows how much money she's going to send him. So, And just to say, there are various ways he can do this. One of the most common ones is as a QR code. So if any of you have done anything with cryptocurrencies, you'll find that you're frequently asked to scan a QR code to send money or something. Okay? So that's not the only way. There's ways you can type addresses and stuff, or other ways. But QR codes seem to be a favorite. Okay, so that's it. I've now done step one. Bob's made an address. Bob's now made an address and sent it to Alice. So Bob has made an address, sent it to Alice, and we're done with that bit. Second part is Alice puts the money on an output. Okay. What does that mean? Right? It essentially means she makes a public key script. She makes a PK script okay. Sometimes called a script pub key. And what it says generally, the most common thing for this to say, and as I've said before, this can happen in other ways as well. There's other things she can say, but the most common thing to say this is the most common thing that PK script can say. It can say to spend the money on the output, or to collect the money on the output. So remember, when I said what the PK script was, I said it gave the conditions under which you can take the money, right? To spend the money in the output, you need two things. You need to provide a number, which is really your public key, such that when I hash it, I get the address. Okay? Remember I told you she has the address. So now I'm just going to check what the PK script says is you're going to now give me your public key, and I'm going to hash it and just see that is the address you gave me, right? Okay? Makes sense? The second thing you're going to have to do is you're going to have to provide proof using your secret key by proof that you have control of that public key. And you do that with this private key signature. So those are the two things that the PK script essentially says. It says, usually, it says to be able to spend this money, you have to show that you've got the public you've got the public key that hashes to the right place, and that you own that public key. Because remember, other people might easily intercept the public key. So you have to prove that as well. So that's the second thing we've done. We've now, and then she puts the money, and that's essentially what putting the money on it means. It says, here's a script, you can spend money from this output under these conditions, okay? Okay, so now, so how far have we got? We've got so far as the money's got onto an output. It hasn't been connected yet. And by the way, this output is now called a UTXO. So the TX is definitely transaction. The O is output. Yeah, the U must be unspent. Okay. So it's unspent. So UT, that's a big phrase. So it's that's not a T. That's got a. Okay. UTXO. A UTXO is an unspent transition output, ready to be spent. Okay. So, how does Bob spend it? Now, Bob collects or spends. That's the third thing that happens. Bob collects or spends the money on the output. How does he do that? Well, he creates an input. And what does the input have on it? Two things. It has the ID of the transaction that we're taking the output from, and the place on the array where that output is. Okay, so it's saying this is saying what output Alice has provided. That's giving us the output that Alice has provided. Okay, yep. And the other thing he provides is a sig script or signature script. And what that has in it is that has all the data you need to establish you meet the PK script requirements. So that's it. So then what has to happen is when the transaction happens, it checks the SIG script, matches the PK script, and then you can take the money from this output essentially into the input. Okay. So I hope that's a little bit clearer. If not, well, it might get clearer when we actually do more work ourselves, but that's how Bitcoin transactions work. We're now ready to do transactions in Ethereum. Ethereum is the second major cryptocurrency, and it's set up to expand what you can do with the whole crypto world. And it's done that very well, and you'll learn more about that later, but we'll talk about that a bit, and there'll be some of it in the readings. So let's start with the transactions in Ethereum, and we'll work out what's different as we go. Okay, Ethereum was proposed in 2013 by Vitek Buterin. People know who Vitek Buterin is. He's very different from Satoshi right there, and he was very young at the time. And I guess he's still pretty young, because it's not that long ago. So it was about 5 years after Bitcoin, and Ethereum is set up to bring in flexible sort of programming into the crypto world. At the time of the writing, the second biggest cryptocurrency. I'm pretty sure it will still be the second biggest cryptocurrency by the time you read this. It's based on Bitcoin in many ways, but it's got the big difference is it's got what are called smart contracts. And smart contracts are, as as I say, they're kind of contracts, they're promises, but they're things that will happen. There's computer programs as well. They're kind of promises that will happen and be affected, will be affected at some point and happen. So we'll talk about that as well. And there'll be more about smart contracts in topics 9 and 10. Up to then, we're not going to do that much. We're much more interested in making a blockchain that looks quite like a slightly simplified version of the Bitcoin one. But, so let me remind you, transactions of Bitcoin and Bitcoin transactions were the primary objects. Transactions had outputs referring to inputs, but it was all about transactions. You have the signatures were all on outputs and inputs, all about transactions. No notion of account or something. Ethereum has accounts, okay? The primary objects in Ethereum are accounts. There are two types. There are what are called externally owned accounts, and there are contract accounts. Okay. What's an externally owned account? Well, an externally owned account is the kind of account you would think of right off the bat. It's where it's just an account really that just has money in it. It's where you keep your money. It's got a name and an owner, and it's got money. The state, but the other thing that's different about Ethereum is states, and that you necessarily have states once you've got these accounts, because having different amounts of money give you in different states. So you have the whole idea of state machines as a way of thinking about the world. That's not in the Bitcoin world at all, though. When Ethereum is being introduced, the Ethereum white paper talks about the state of the Bitcoin world, but there's nothing like that in Satoshi's view. Okay. Now, because we don't have accounts really, we just have those transactions. So an externally owned account has a name, and then it has a state, and the state is how much money is in the account, and a nonce. And what a nonce is, for a long time I thought a nonce stood for nonsense, but it doesn't. It stands for something that only happens used once. And that's the point of a nonce. It's only used once. And what you do is with all sorts of things that you sign, and we'll see it used in signatures in Bitcoin and also in mining. But the idea is it's something that's kind of nonsense. But when you sign something that includes the nonce, it's only going to be workable really with that nonce again. And what happens in Ethereum is that the nonce updates every time you make a new transaction. So you don't have the same nonce again in the same account. So nobody can sign, having seen your signature once, use your signature again and say, oh, the guy whose account this is signs like this. No, because you need a new signature which will be different with a different nonce. So having the signature once from one transaction is no good to try to forge it with the second one. Okay, so this is what a transaction looks like. This is what's called an external transaction. It goes from one externally owned account to another. It's got from and to addresses and a value. So that's all pretty obvious. The next thing is it's got gas is the unit for paying into the system. It gets pays the miners. And you say two things about this. This sort of works in Bitcoin as well. I don't know if I mentioned it yet, but you've got fees in Bitcoin. When you make a transaction, you have a fee, and that fee gets paid to the miner or to put your transaction on the block. So it's a kind of bribe to put your transaction on the block, or a payment to put your transaction on the block. So this is the same idea. So it's a little bit more complicated. You've got two variables. One is the maximum amount of gas you're willing to pay for this transaction. And the second one is the maximum amount of ether you're willing to pay for every unit of gas. So between them, they tell how much ether you pay for a transaction. And the data is extra information, and that's really not that different from the extra information you have in when you do bank transactions now. You might say something like, "This is for my rent." And a signature, there's one signature, and the signature of the person who is sending the money. Now, the second kind of account you've got is called a contract account. It's got an account signifier again and a state again, and that's all the same. But what's new is you've got a contract. And the contract is something that will be enacted as soon as the contract receives a message or a transaction. As soon as the transaction comes to that contract will enact its contract. And that's we'll see an example of this. And that contract can do all sorts of things. One of the things it can do is it can actually take the amount of money it receives and split it up into other people. If you think about it, the transactions we talked about before, the external transactions had one recipient and one sender. But if you wanted to send to 6 different people, a contract can do that for you, for example. It can change storage. It can keep track of things. It's all sorts of things a contract can do, and you'll see much more of that later. And that's what opens up blockchain to a lot of applications outside of currency. These smart contracts. One of the things is, I don't know how many of you have heard of what are called ICOs, or initial coin offerings. They're like initial public offerings of shares, but people use these smart contracts as a way of having, instead of going to the stock market, having coin offerings as a way of getting money in for people to own part of something. I'm not going to talk about this now, but more than that. But those are called initial coin offerings, and you couldn't really do that with Bitcoin. You needed the idea of contracts. So here's the transaction. Now, I've talked about there being a state of each account. There's also a state of the whole world. The state of the whole world is the sum of the states of all the accounts in the world. So this is a transaction changes the state of the world. It changes the state of some accounts, so it changes the state of the world. This example comes from the Ethereum white paper. It is a contract transaction. It's a transaction from an externally operated and externally owned account to a contract account, and the accounts involved are the 2 top ones on this state this chart of states, this state chart. So let's think what it does. Let's look at what the transaction says it does. It says it moves 10 ether from the count on the top to the count on the bottom. So I've got the names of the accounts. That's how I did not the count on the bottom, the second account. I have the names on the account, so that's how I know which accounts we're talking about. Okay, so it moves 10, and one of the things you can see is the amount of ether in this account before the transaction is 1024 and after the transaction is 1014. So that's the only change that happens in that state, in that account. The state changes by lowering the amount of ether by 10. The nonce will change as well, but the nonce is being looked at in this diagram. Okay, right. Now, more interestingly in a way, is what's happening to the second account, because that's a contract account, and it's receiving this money, So it's gone from 5202 to 5212. It has received the money just as much as the externally owned account did. That sense of money being part of the state is still there. But something else has happened. And what's happened is this contract has kicked in. Okay? And the contract, the data for this contract comes here. Here's the data for the contract. Okay, and what this contract is saying is that I'm going to update the storage of this contract, of this account. And how am I going to update the storage? Well, I'm going to update the storage by changing this is an array, so the second thing in the array is really the third, because you start with 3, and you're going to change it so that it becomes Charlie. So remember, so you see, before this transaction happens, the second thing, or the thing indexed by 2, the third thing is 0. After the account, after the transaction, it's Charlie. That transaction has changed that state by making that contract change the storage. I desperately need to go off, so I'm signing off here quickly. Okay, bye-bye. Okay, we're now just going to do our transactions in another cryptocurrency. This one's called Monero. And the reason I'm talking about this one is not that we're going to use it really, it's that it's just really interesting. It's what's called a privacy coin, which means that it's got privacy beyond Bitcoin and Ethereum. People used to talk about Bitcoin as a currency for drug dealers. Well, it's not nearly as good as Monero is for that. And there's other privacy coins as well, but Monero, I think, was the first and probably the best known of the privacy coins. And from my point of view, I'm not using it as a drug dealer, but I am interested in it from a cryptography point of view, because it's really just, and the mathematical cryptography, it's just really interesting. It's to doing things that include the things we've done before, but things that we haven't thought about before. So what I'm going to do is take you through this, and the details will be quite sketchy, but you'll have the notes if you want to learn more. And those of you who want to implement this sort of thing as part of your coursework would be great. I'd be very excited to see some of that. And let's talk about transactions in Monero. From 0 to Monero and back again. Okay, here we go. Hold on, zero hats. Okay, how private are cryptocurrencies? Well, Bitcoin and Ethereum is similarly private, I suppose. The owner of the address is anonymous. You have no way of knowing who the owner of an address is until you tell somebody to pay you. And when you tell somebody to pay you, well, I think it depends how much information you have to give away, but they at least then know that wallet. You might have lots of different wallets. It might not be such a big deal, but the owner of the address is anonymous. That's true, but whenever you do a transaction, everybody can see the transaction. Everybody can see all the transactions going to and from a particular address. So even if I don't know who owns that address, they know all the transactions associated with that address if they want to. That doesn't change. That's something you can just do. Monero is more private than that. And so, what I said before, it's called a privacy coin. So, what else might I want to hide? I'm going to hide actually the amount of each transaction. Really? I'm going to hide where the money's come from. I'm going to hide which outputs are controlled by which addresses. So, you know, we had all of these outputs and things, and you could tell all these signatures of things from other currencies. We're making all of this hidden. And we're going to do all of this without sacrificing the security we get from consensus protocols. So how are we going to do this? It seems impossible, right? I mean, well, this is how you do it. Okay, let me just give you a clue. The clue is you hide everything, or you hide outputs among other outputs. For example, okay, we'll see how this works. So Monero is a transaction-based, like Bitcoin. So in that sense, it's more like Bitcoin than like Ethereum. An input to one transaction is an output from another. So that's just like Bitcoin, right? However, what we're going to do now is we're going to hide the output that we're taking the money from. The way you do that is you say, okay,